Hello, in this lecture we will find out the area of quadrilateral ABCD using two different methods. In the drawing we have quadrilateral ABCD. We know that side AB equals to 4 units, side DC equals to 2 units, and we also know that AD equals to CB, and angle BAD, this angle equals to 30 degrees, angle ABC equals to 90 degrees, and we want to find out the area of quadrilateral ABCD. So we will start with the first method. In the first method, we will draw perpendicular from point D to AB. And we will define the touching point between the perpendicular and AB as point E. So this angle is the right angle, it equals to 90 degrees. And this angle, it is also a right angle, it equals to 90 degrees. We will define line segment DE as A. We will focus on triangle AED. On triangle AD, we know that sinus 30 degrees equals to DE over AD. And triangle ADE, this will be question number 1. In triangle ADE, sinus 30 degrees equals to DE over AD. DE equals to A units according to our definition over AD. And sinus 30 degrees is 1 over 2. So I write it down. We get that 1 over 2 equals to A over AD. Here we will multiply this equation number 1 by AD. And we also multiply the equation by 2, so we will cross multiply equation number 1. And we will get that AD equals to 2A. So we write down that AD equals to 2A. In the next step, from point D we will draw perpendicular to CB. We will define the touching point between the perpendicular from D to CB as point F. So this angle equals to 90 degrees, and this angle is also equal to 90 degrees. In the next step, I will present to you a new rule. This will be actually rule number 1. According to rule number 1, the sum of the angles in any quadrilateral is equal to 360 degrees so according to rule number 1, the sum of the angles in quadrilateral DFEB must be equal to 360 degrees. So in quadrilateral DFBE we have 3 right angles. And the sum of 3 right angles is equal to 3 times 90. That is actually 270 degrees. Plus the 4th angle, this angle EDF that we define as angle X. In total, the sum of those 4 angles must be equal to 360 degrees. Here we'll subtract from this equation 270 degrees and we will get that angle X equals to 360 degrees plus 270 degrees is equal to 90 degrees. So we found out that angle X is a right angle, that is to say it equals to 90 degrees. So we will substitute angle X by a right angle. You can see from the drawing that quadrilateral DFBE has 4 right angles, and we have also rule number 2. According to rule number 2, any quadrilateral that has 4 right angles must be at least a rectangle if not a square. So if not a square, it must be a rectangle. So I'll read rule number 2 again. According to rule number 2, any quadrilateral that has 4 right angles must be at least a rectangle if not a square. So our quadrilateral DFBE has 4 right angles. Therefore, we will relate its quadrilateral DFBE relate to quadrilateral DFBE as a rectangle according to rule number 2. Okay, quadrilateral DFBE is a rectangle according to rule number 2. And we have also rule number 3. According to rule number 3, the opposite sides of a rectangle are equal to each other. And repeat on rule number 3 again. According to rule number 3, the opposite sides of a rectangle are equal to each other. So we know that quadrilateral DFBE is a rectangle, so its opposite sides must be equal to each other. That is to say, according to rule number 3, ED equals to FB. ED of DE equals to FB, according to rule number 3. But according to our definition, DE equals to A units. So DE equals to A. And from this equation, we derive that FB also equals to A. FB also equals to A units. So we can write here that FB equals to A units. In the next step, we will join points D and B together by a straight line. And actually CF is equal to we know that AD equals to CB. Again, according to what is given us in the question, AD equals to CB. Okay? AD equals to CB, but we have already found out that AD equals to A, so CB must be also equal to 2A. CB must be also equals to 2A. And there, what is the value of FC? FC equals to CB minus FB. I'll repeat again. FC or CF equals to CB minus FB. So CF equals to CB, that is actually 2A, minus FB, that is actually A. So CF equals to 2A minus A, that is A. We found out that CF equals to A. Right here that CF equals to A. In the next step, we will prove the triangle DFC, this triangle, the right triangle, triangle DFC, congruent to the right triangle, triangle DFB, this right angle. So, why those two right triangles congruent to each other? First of all, we know that CF equals to FB equals to A. I repeat again. CF equals to FB equals to A units. We also know that those two angles, they are equal to each other, they are both equal to 90 degrees, so angle CFD equals to angle BFD, this angle, and both angles, they are right angles, that is to say they are equal to 90 degrees. So angle CFD equals to angle BFD equals to 90 degrees. They are both right angles. And we also have here a common side. That is to say DF is a common side, it belongs to both triangles. So DF equals to itself. DF equals to DF is a common side that belongs to both triangles. Here, DF equals to DF is a common side that belongs to both triangles. Therefore, we actually proved that the right triangle, triangle DFC, congruent, this is the sign of congruent, to the right triangle, triangle DFB, according to side angle side rule. Okay. We have two sides and the angle between them and triangle DFC that congruent to two sides and the angle between them and triangle DFB. Therefore, those two triangles congruent to each other according to side angle side rule. And we will conclude from it that DC equals to dB. DC equals to dB according to the rule that corresponding sides in congruent triangles are equal to each other. But it is given us as a question that DC equals to 2 units. Therefore, from this equation, we will derive that dB also equals to 2 units. So we can write here that dB equals to 2 units. In the next step, I will present to you a new rule or a new law, the law of cosines. The law of cosines is true for any triangle. So if we have triangle ABC, this is triangle ABC, this is the angle theta, the length of side AB is A units, the length of side BC is B units, and the length of side AC is C units. Then, according to the law of cosines, A squared plus B squared minus 2 times AB times cosine theta equals to C squared. Here we will subtract C squared from this formula and we will add to this equation 2AB cosinus theta, and we will get that A squared plus B squared minus C squared equals to 2AB cosinus theta. So here we will divide this equation by 2AB, and we will get that cosine theta equals to A squared plus B squared minus C squared over 2AB equals to cosine theta. Okay, so it is true for any triangle that cosine theta equals to A squared plus B squared minus C squared minus 2 times AB. We can implement the law of cosines. So it is actually the law of cosines. I will write it here. It is the law of cosines. We can implement the law of cosines in our drawing. We will implement the law of cosines in triangle ADB. So in triangle ADB, so I will copy triangle ADB in the new page, and we will analyze the triangle. We will implement the rule on triangle ADB. So actually, according to the law of sine, the law of cosines, if we implement the law of cosines on triangle ADB, we will get that cosine 30 degrees equals to 2a squared plus 4 squared minus minus 2 squared over 2 times 2a times 4. Okay, and we know that cosine 30 degrees is square root of 3 over 2, and it equals to 2a squared is 4a squared, 4 squared is 16, and 2 squared is 4, so 16 minus 4 is 12, over 2 times 4 is 8, and 8 times 2 is 16, so here we will get in the denominator 16a. So we will multiply this equation by 16a, and we will get that square root of 3 over 2 times 16a equals to 4a squared plus 12, so 16 over 2 is 8, so we got 8 times square root of 3 times a equals to 4a squared plus 12. Here we will divide this equation by 4, and we will get that 4 over 8 over 4 is 2, so it is 2 times square root of 3 times a. 4 over 4 is 1, so here we will get a squared plus 12 over 4 is 3. We will subtract 2 times square root of 3a from this equation, and we will get that a squared, and actually 3 is square root of 3 squared minus 2 times a times square root of 3 equals to 0. This equation is very similar to the algebraic identity that a squared plus b squared minus 2 times ab equals to a minus b squared, that equals to 0. In our specific equation, we know that a equals to a equals to a, and b equals to square root of 3. So a minus b squared will be actually a is a, and b is square root of 3, so it is a minus square root of 3 square equals to 0. Okay, so we actually got that a minus square root of 3 square equals to 0, Here we will take a root out of this equation, and we will get that the square root of 0 is 0. So we will get that a minus square root of 3 equals to 0. Here we will add square root of 3 to this equation, and we will get that a equals to the square root of 3. So here we can write down that a equals to the square root of 3. Here also a equals to the square root of 3, and a equals to the square root of 3 units. And in the next step, we will focus on the right triangle DEB. On the right triangle DEB, according to the Pythagoras theorem, DE square plus EB square equals to DB square again in the right triangle DEB, according to the Pythagoras theorem, DE square plus EB square equals to DB square. DE equals to square root of 3, so DE square is square root of 3 squared, that is 3, plus EB square equals to DB square. DB is 2, so DB square is 2 squared. This 2 squared is 4. So here we will subtract 3 from this equation, and we will get that EB square equals to 4 minus 3, that is to say it equals to 1. Here we will take a root out of this equation, and we will get that EB equals to the square root of 1, that is 1. So we found out that EB equals to 1. EB equals to 1. And according to the rule that the opposite sides of a rectangle are equal to each other, it means that EB equals to DF, but EB equals to 1, so DF will be also equal to 1. And what is the value of AE? AE equals to AB minus EB. AB minus EB equals to AE. So AE equals to AB, that is 4 units, minus EB, that is 1. 4 minus 1 is 3, so AE equals to 3 units. AE equals to 3 units. So, what is the area of quadrilateral ABCD? The area of quadrilateral ABCD will be equal to the area of triangle ADE plus the area of rectangle DFEB plus the area of triangle DCF. A right triangle, triangle DCF. So I'll repeat again. The area that we are looking for, that is the area of quadrilateral ABCD, equals to the area of triangle ADE plus the area of rectangle DFEB plus the area of the right triangle, triangle DCF. Okay? And the area of triangle AED is equal to the base of the triangle that is actually AE times the height to the base that is actually DE over 2. I repeat again, the area of triangle ADE equals to AE times DE over 2, and the area of rectangle DFEB will be equal to EB, that is actually 1 unit, times EB, that is actually square root of 3. I'll repeat again. The area of rectangle DFEB equals to EB times ED EB times ED, and the area of triangle DCF, it equals actually to the base of the triangle that is actually DF, that equals to 1 times FC. FC, that is actually equals to square root of 3 units. So actually, I found out the area of quadrilateral ABCD, that is actually the sum of those three areas. So, and the area of triangle ADE is equal to AE equals to 3 units times DE equals to square root of 3 units over 2. So we found out that the area of triangle ADE equals to 3 times square root of 3 over 2 plus the area of rectangle EBDF, that is actually equal to EB, that is 1 unit, times ED, that is square root of 3. So the area of rectangle EBDF is actually square root of 3 units, plus the area of triangle ECD, that is actually DF equals to 1 times FC, that is actually square root of 3, that is A, that is square root of 3 over 2. It is a triangle, so we must divide it by 2. So in conclusion, we found out that the area of quadrilateral ABCD is equal to the sum of those three expressions. Here we will multiply square root of 3 by 2, and then we will divide it by 2 in order to have a common factor with the other two expressions. Okay. So we will get that the area of quadrilateral ABCD, in the denominator we have 2, in the numerator we have 3 times square root of 3 plus 2 times square root of 3 is 5 times square root of 3, and 5 times square root of 3 plus 1 times square root of 3 is 6 times square root of 3 over 2. 6 over 2 is 3. So in conclusion, we found out that the area of quadrilateral ABCD equals to either 3 times square root of 3 units, square root of 3 square units, or in terms of numbers, it equals to 5.196 square units. Okay, so we finished with the first method. In the next step, I will present to you how to find out the area of quadrilateral ABCD. This quadrilateral according to a second method. In the second method, we will do a construction. From point A, we will make a perpendicular to AB. So this angle will be equal to 90 degrees. It will be a right angle. And from point C, we will draw perpendicular to BC. So actually, this angle will be equal to 90 degrees. It is a right angle because we drew perpendicular to point C. And we will define the intersection point between the perpendicular from point A and the perpendicular from point C as point E. So we have here quadrilateral ABC, ABCE. In quadrilateral ABCE, we have 3 right angles, 1, 2, 3. The sum of those 3 right angles is 90 degrees times 3 is 270 degrees, plus the fourth angle that will define as angle X. So the sum of those 4 angles, the sum of those 4 angles must be equal to 360 degrees, according to rule number 1, that the sum of the angles in any quadrilateral is equal to 360 degrees. So here we will subtract 270 degrees from this equation, and we will get that X equals to 360 degrees minus 270 degrees. That is to say, X equals to 90 degrees. So we found out that angle X, it is a right angle, it equals to 90 degrees. So we will substitute X by a right angle. So actually, quadrilateral ABCE has 4 right angles, and according to rule number 2, any quadrilateral that has 4 right angles must be at least a rectangle. So we will relate to quadrilateral ABCE as a rectangle. So quadrilateral ABCE is a rectangle according to rule number 2. Okay, and according to rule number 3, the opposite sides of a a rectangle are equal to each other, so the opposite sides of quadrilateral A, B, C, E are equal to each other, so AB is equal to EC. AB equals to EC. AB equals to EC according to rule number 3. But we know it is given us in the equation that AB equals to 4. So from this equation, we will get that CE also equals to 4. CE equals to 4 units. So we can write here that CE equals to 4 units. Likewise, CB will be equal to EA. Those two opposite sides in quadrilateral ABCE are equal to each other. So CB equals to EA. According to rule number 3, that the opposite sides of a rectangle are equal to each other. And if we define CB as x, if CB equals to x, then from this equation we will derive that EA also equals to x. EA also equals to x. In the next step, we will join together points D and B by a straight line. And we will also join together points D and E by a straight line. Angle EAB is equal to 90 degrees and angle BAD equals to 30 degrees. So if we subtract 90 degrees, 30 degrees from this angle that equals to 90 degrees, we will get angle EAD that will be equal to 60 degrees, because 90 degrees minus 60 degrees, 90 degrees minus 30 degrees is 60 degrees. So we got that this angle equals to 60 degrees. Angle DAE equals to 60 degrees. So we will focus on triangle EAD. I will copy again in a new page triangle EAD and we will analyze triangle EAD. Okay. So triangle EAD. Actually, before that, we know that BC equals to AD. It is given us the question that BC equals to AD here. BC equals to AD. So, but if BC equals to X, then DA also equals to X. So you can see that in triangle AED we have two sides that are equal to each other. So I will copy again triangle AED. So this is triangle AED. We know that those two sides are equal to each other, they are both equal to x. And we have the rule that in front of equal sides in a triangle, there are equal angles. So those two angles that are located in front, the equal angles, must be also those two angles that are located between in front of the equal sides must be also equal to each other. So this angle equals to this angle. And if we define angle AED as y, then angle ADE must be also equal to y. And we know that the sum of the angles in any triangle is equal to 180 degrees. So here we have 60 degrees plus angle y plus angle y must be equal to 180 degrees. Here we will subtract 60 degrees from this equation and we will get that y plus 2y plus y plus y is 2y. 2y equals to 180 degrees minus 60 degrees, that is to say it equals to 120 degrees. We will divide this equation by 2 and we will get that angle y equals to 60 degrees. We found out that angle y equals to 60 degrees. So those two angles, they are equal to 60 degrees. Therefore, triangle AED is an equilateral triangle. Equilateral triangle that is to say all of its sides are equal to each other, so ED will be also equal to x, and all of its angles are equal to 60 degrees. Okay? So here we know that ED equals to x. This angle equals to 60 degrees because of the fact that triangle AED is an equilateral triangle. So we know that angle AEC is a right angle. It is one out of 4 angles of rectangle AECB. And angle AED equals to 60 degrees. So 90 degrees minus 60 degrees will be equal to 30 degrees. That is actually the value of this angle. Angle DEC equals to 30 degrees. Okay? And here we will focus on triangle EDC. So in the next step, we will prove that triangle ADB is perpendicular to triangle EDC. I will write it again, triangle ADB, this triangle, will prove that triangle ADB, this triangle, is perpendicular to triangle EDC, this triangle. So why those two triangles can point to each other? First of all, we know that AB equals to EC equals to 4 units. AB equals to EC equals to 4 units. AB equals to EC equals to 4 units. We also know that those two angles are equal to each other. They are both equal to 30 degrees. So angle BAD of this angle is equal to angle DAC of this angle, DEC of this angle, triangle DEC, and both angles are equal to 30 degrees. So I'll repeat again, angle BAD equals to angle DEC, and they are both equal to 30 degrees. And we also know that AD equals to ED. AD equals to ED equals to X. 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 So we actually proved that triangle ADB, this triangle, congruent to triangle EDC, triangle ADB congruent to triangle EDC according to angle side angle rule. You can see here those two angles and those two sides and the angle between them, this is to say this angle that equals to 30 degrees, congruent to those two sides and the angle between them that is also equal to 30 degrees in triangle DCE. So those two triangles congruent to each other according to angle side angle rule. From the fact that those two triangles congruent to each other, we will conclude that DC equals to DB. DC equals to DB. DC equals to DB according to the rule that corresponding sides and congruent triangles are equal to each other. Those two triangles congruent to each other, therefore the corresponding sides DC and DB will be equal to each other. But DC equals to 2 units, it is given us in the question. From this equation we will derive that DB also equals to 2 units. DB equals to 2 units. So in the next step we will implement the law of cosines on triangle ADB. Okay. According to the law of cosines, if we focus on triangle ADB, cosine 30 degrees equals to x squared plus 4 squared minus 2 squared over 2 times x times 4. I will repeat again. According to the law of cosines on triangle ADB, cosine 30 degrees equals to x squared plus 4 squared minus 2 squared over 2 times x times 4. So here cosine 30 degrees is equal to square root of 3 over 2, and it equals to x squared plus 4 squared is 16, minus 2 squared is 4, and 16 minus 4 is 12, so in the numerator we will have x squared plus 12, and in the denominator we have 2 times 4 is 8, so 8 squared, 8x. We will multiply this equation by 8x, and we'll get that square root of 3 over 2 times 8x equals to x squared plus 12. Here 8 over 2 is 4, so we will get that 4 times square root of 3 times x equals to x squared plus 12. We will subtract 4 times square root of 3x from this equation, and we will get that x squared plus 12 minus 4 times square root of 3 times x equals to 0. 12 is 2 times square root of 3 squared, so we will write down that x squared plus 12 is 2 times square root of 3 squared, and 4 times square root of 3 square x is 2 times x times 2 square root of 3, that equals to 0. This equation is very similar to the algebraic identity that states that a squared plus b squared minus 2 times ab equals to a minus b squared, and it equals to 0. Here, in our specific expression, a equals to x and b equals to 2 times square root of 3. So actually a minus b squared is a is x, b is 2 times square root of 3. We will square it and it must be equal to 0. So here we will take a root out of this equation and we will get that the square root of 0 is 0, so x minus 2 times square root of 3 equals to 0. We will add 2 times square root of 3 to this equation and we will get that x equals to 2 times square root of 3 units. So found out the value of x. X equals to 2 times square root of 3 units. So we can write here that x equals to 2 times square root of 3 units. Also here x equals to 2 times square root of 3 units. And here also equals to, x equals to 2 times square root of 3 units. So we have to find out the value of quadrilateral ABCD. And the value of quadrilateral ABCD, it composes of 2 triangles. It will be equal to the sum of the areas of triangle ADB plus triangle BDC. So the area of quadrilateral ABCD will be equal to the area of triangle ADB the area of triangle ADB plus the area of triangle BDC. I'll repeat again. Quadrilateral ABDC composed of two triangles, and the area of quadrilateral ABCD will be equal to the sum of the areas of the two triangles, triangle ADB plus the area of triangle BDC. Okay, what is the area of triangle ADB? The area of triangle ADB, first of all, from point D, we will draw perpendicular to AB, and this will be the height to the base. We define it as the height, it will be equal to h, it's the height to the base AB. So the base AB is 4 units and the height is h. What is the value of the height h? The value of the height h, if we focus on triangle AD, we define this point as point S. So in triangle ADS, we know that sinus 30 degrees, this triangle, equals to h over AD, that is actually 2 times square root of 3. I'll repeat again. In triangle ADS, sinus 30 degrees equals to h over 2 times square root of 3. We will multiply, first of all, sinus 30 degrees equals to 1 over 2. So we write it down. One over 2 equals to h over 2 times square root of 3. Here we will multiply this equation by 2 times square root of 3, and we will get that h equals to 2 times square root of 3 over 2. 2 over 2 is 1, so it is square root of 2. So we found out that h equals to the square root of 3 units, and therefore the area of triangle ADB will be equal to the base AB times the height over 2. The base, the area of triangle ADB equals to the base AB times the height to the base h over 2. The area of triangle ADB equals to the base AB times the height to the base, that is h over 2. But we already know that AB equals to 4 units, h is equal to the square root of 3 units over 2. So the area of triangle ADB is AB, that is 4 times h, that is square root of 3 over 2. 4 over 2 is 2. So in conclusion, we found out that the area of triangle ADB, it is actually 2 times square root of 3 square units. The only thing that is left to do is to find out the area of triangle BDC. We'll find out the area of triangle BDC. This triangle BDC. According to the formula S, that is S is the semi-perimeter of any triangle, and the semi-perimeter of any triangle is equal to the perimeter over 2. The semi-perimeter of triangle BDC will be equal to the sum of its sides, of the left sides, that is to say to A plus B plus C, and we will divide it by 2 in order to get the semi-perimeter. The perimeter is A plus B plus C, and if we divide the perimeter by 2, we will get the semi-perimeter. That is actually A plus B plus C over 2. So A is 2, B is 2, and C is 2 times square root of 3. So S equals to A, that is 2, plus B, that is 2, plus C, that is 2 times square root of 3, all divided by 2. 2 plus 2 is 4. 4 plus 2 times square root of 3 over 2. That is to say, it equals to 4 over 2 is 2, and 2 times square root of 3 over 2 is square root of 3. So in conclusion, we found out that S equals to 2 plus square root of 3 units. So we found out the semi-perimeter of triangle BDC, and the area of triangle BDC. The area of triangle BDC will be equal to the square root of S times S minus A times S minus B times S minus C. And we know that S equals to 2 plus square root of 3. So we will put the value of S inside the formula for the area, and we will get that the area of triangle BDC equals to the square root. S is 2 plus square root of 3, and S minus A equals to 2, B equals to 2, and C equals to 2 times square root of 3. So here S minus A is 2 plus square root of 3 minus 2 is square root of 3 units. S, that is actually S minus A. S minus B is the same result, because A equals to B. It is also square root of 3 times S minus C. S minus C is 2 plus square root of 3 minus 2 times square root of 3. We will get that S minus C it equals to 2 minus square root of 3 units. And it equals to the area of triangle BDC will be equal to square root of 3 times square root of 3 is 3. And here we have 2 plus square root of 3 times 2 minus square root of 3. It is, we will solve this multiplication according to the algebraic identity that states that A plus B times A minus B equals to A squared minus B squared. Here A is 2 and B is square root of 3, so A squared is 4, and minus B squared is minus 3, minus square root of 3 squared, it is actually 3. Okay, so the area of triangle BDC, it will be equal to the square root of 3 times 1. 3 times 1 is 3. So the area of triangle BDC is equal to the square root of 3 square units. And the area of quadrilateral ABCD will be equal to the area of triangle ADB plus the area of triangle BDC. Okay, I repeat again, the area of quadrilateral ABCD equals to the area of triangle ADB plus the area of triangle BDC. We have already found out that the area of triangle ADB equals to 2 times square root of 3 square units, and the area of triangle BDC equals to square root of 3 square units, and 2 times square root of 3 units plus 1 times square root of 3 units equals to 3 times square root of 3 units. And in terms of numbers, it equals to 5.196 square units. We finished with the second method. Now I will summarize the lecture. Actually, we wanted to find out the area of this quadrilateral ABCD, and we found out the area of this quadrilateral in 2 different methods. In the first method, we actually here we drew perpendicular from point D to AB. We drew perpendicular from point D to AB. We defined the touching point between the perpendicular from D to AB as point E. So this angle equals to 90 degrees, and this angle also equals to 90 degrees. So in triangle ADE, and we find DE, we defined line segment DE as A. And in triangle ADE, we know that sinus 30 degrees equals to DE over AD. Here, sinus 30 in triangle ADE, sinus 30 degrees equals to DE over AD. DE equals to A units according to our definition, and AD equals to AD. So, and we know that sinus 30 degrees equals to 1 over 2. So 1 over 2 equals to A over AD. We multiplied, because multiplied this equation number 1, and we got that AD equals to 2A. So we found out that AD equals to 2A. But we know that according to what is given us in the question, AD equals to BC. AD equals to BC. AD equals to BC. Here you can see that AD equals to BC of CB. And AD equals to 2A. So BC will be also equal to 2A. Will be also equal to 2A. And then, so this angle equals to 90 degrees. This angle equals to 90 degrees according to what is given us in the question. And we drew perpendicular from point D to CB. So this angle equals to 90 degrees, and this angle also equals to 90 degrees. So actually quadrilateral DEBF is 3 right angles. And we have rule number 1. According to rule number 1, any quadrilateral that's actually rule number 2. According to rule number 1, the sum of the angles in any quadrilateral is equal to 360 degrees, and especially the sum of the angles in quadrilateral DFBE must be equal to 360 degrees. Quadrilateral DFBE has 3 right angles. The sum of those 3 right angles is 90 degrees times 3 is 270 degrees. plus the size of the fourth angle that we will define as x must be equal to 360 degrees according to rule number 1. 270 degrees plus angle x must be equal to 360 degrees according to rule number 1. We subtract 270 degrees from this equation and we got that angle x equals to 90 degrees. So we found out that angle x equals to 90 degrees, that is to say quadrilateral DFBE has 4 right angles, and according to rule number 2, any quadrilateral that has 4 right angles must be at least a rectangle if not a square. So we can relate to quadrilateral DFBE as a rectangle because it has 4 right angles. According to rule number 2, quadrilateral DFBE is a rectangle. And we have also rule number 3 that states that the opposite sides of a rectangle are equal to each other. So in rectangle DFBE, its opposite sides are equal to each other. That is to say, DE equals to FB, DE equals to FB, but according to our definition, DE equals to A. So from this equation, we will derive that FB also equals to A. So here, FB also equals to A. And what is the value of CF? I mentioned before 2 minutes ago that AD equals to CB according to what is given as the question, but because of the fact that AD equals to 2A, then CB also must be equal to 2A. And what is the value of CF? CF equals to CB minus FB. CF equals to CB minus FB. CF equals to CB minus FB. So CF equals to CB, that is 2A, minus FB, that is A, and 2A minus A equals to A. So we found out that CF equals to A. CF equals to A. Then we proved that those two triangles can go into each other. Why those two triangles can go into each other? So first of all, we proved the triangle DFC can go into triangle DFB. Why? Because CF equals to FB equals to A. Those two angles, those two sides, they are equal to each other, they are both equal to A units. Those two angles, they are equal to each other, they are both equal to 90 degrees. So angle CFD equals to angle BFD equals to 90 degrees. And those two triangles has a common side, DF is a common side, it belongs to both triangles. So actually those two triangles can go into each other according to side angle side rule. Triangle DFC can go into triangle DFB according to side angle side rule. We can conclude from it that BD equals to DC, DC equals to BD, but we know that DC equals to 2 units. DC equals to 2 units according to what is given us in the question. From this equation we will derive that BD also equals to 2 units. So here BD equals to 2 units. Okay. Then I presented to you the law of sines. What is the law of sines? Actually, the law of cosines This is actually the law of cosines. That is true in any triangle. In any triangle, if we have triangle ABC, that it could be any triangle. We know that the length of side AB is A units, the length of side AC is C units, and the length of side BC is B units, and angle ABC equals to theta. Then according to the law of cosines, A squared plus B squared minus 2 times AB cosine theta equals to C squared. Here we will subtract C squared and add 2AB cosine theta to this equation, and we will get that A squared plus B squared minus C squared equals to 2AB cosine theta. We will divide this equation by 2AB and we will get that cosine theta equals to A squared plus B squared minus C squared over 2 times AB. It is true in any triangle. So we implemented the law of cosines in our triangle ADB. I drew triangle ADB in a new page, and we implemented the law of cosines in triangle ADB. This is triangle ADB. Angle DAB equals to 30 degrees, AD equals to 2A units, DB equals to 2 units, and AB equals to 4 units. Therefore, according to the law of cosines, cosine 30 degrees equals to 2A squared plus 4 squared minus 2 squared over 2 times 2A times 4. So here 2A squared is 4A squared. Cosine 30 degrees is square root of 3 over 2. 2A squared is 4A squared. 4 squared is 16. Minus 2 squared is 4. 16 minus 4 is 12. So in the numerator we have 4A squared minus plus 12. And in the denominator we will have 2 times 4 is 8, and 8 times 2A is 16A. In the denominator we have 16A. Here we multiply this equation by 16A, and we got the square root of 3 over 2 times 16A equals to 4A squared plus 12. And here 16 over 2 is 8. So in this side we will have 8 times square root of 3 times 8. In this side we have 4A squared plus 12. We divided this equation by 4, and we got that 2 times square root of 3 A equals to A squared plus 3. We know that 3 is square root of 3 squared, so we substitute 3 by square root of 3 squared, and we subtracted 2 times square root of 3A from this equation, and we got in conclusion that A squared plus square root of 3 squared minus 2 times A times square root of 3 equals to 0. It is very similar to the algebraic identity that A squared plus B squared minus 2 times AB equals to 0, and A squared plus B squared minus 2 times AB, it equals to actually here it equals to A minus B squared. A squared plus B squared minus 2AB equals to A minus B squared, and it equals to 0. Here also it equals to 0. So we can substitute this expression by A minus B squared. When A is equals to A, B equals to square root of 3. Therefore A minus B squared is A minus square root of 3 squared, that equals to 0. We took a root out of this equation, and the square root of 0 is 0. So we got that A minus square root of 3 equals to 0. We added square root of 3 to this equation, and we got that the value of A is square root of 3 units. Then we implemented the Pythagoras theorem in triangle DEB. This triangle, according to the Pythagoras theorem, in the right triangle DEB, DE square plus EB square equals to DB square. DE square plus EB square equals to DB square. DE equals to square root of 3. Square root of 3 square is 3 plus EB square equals to DB square. DB is 2, so DB square is 2 square. 2 square is 4. Here we subtracted 3 from this equation and we got that EB square equals to 4 minus 3 is 1. So EB square equals to 1. We took a root out of this equation and we got that EB equals to the square root of 1 is 1. So EB equals to 1. We found out that EB equals to 1. But because of the fact that the opposite sides of a rectangle are equal to each other, therefore DF will be also equal to 1. And now we can calculate the area of quadrilateral ABCD. The area of quadrilateral ABCD equals to the area of triangle ADE plus the area of rectangle DEBF plus the area of the right triangle, triangle CDF or DCF. So the area of the right triangle, triangle ADE equals to AE times DE over 2. AE times DE over 2. The area of rectangle DEBF is equal to EB times DE. EB times DE. And the area of the right triangle, triangle DCF equals to DF times CF over 2, of course. DF times CF over 2. So here AE, what is the value of AE? AE equals to 3. DE equals to square root of 3. So 3 times square root of 3 over 2. This is the area of triangle ADE. The area of rectangle DFEB equals to EB times DE over 2. EB is 1. DED, EB is 1 times ED. ED is square root of 3 units, so 1 minus square root of 3 units over 2 is the area of triangle, the area of rectangle DEFE it is actually 1 times square root of 2. And the area of the right triangle, triangle DFC equals to DF times CF. That is, DF is 1 and CF is square root of 2, so it is 1 times square root of 3. CF is square root of 3, all divided by 2. So here we multiplied square root of 3 times 1, we multiplied by 2 and then we divided by 2 in order to overcome a factor with these expressions. And in conclusion, we got that in the denominator we have 2, and in the numerator we have 3 times square root of 3 times 2 times square root of 3 is 5 times square root of 3, and 5 times square root of 3 plus 1 times square root of 3 is 6 times square root of 3, and in the denominator we have 2. So 6 over 2 is 3, so in conclusion we got that the area of quadrilateral ABCD equals to either 3 times square root of 3 square units, or in terms of numbers, it equals to 5.196 square units. We finished with the first method. Then I presented to you how to find out the area of quadrilateral ABCD according to a second method. In the second method, we actually do another construction. Here, from point A, we drew perpendicular to AB, so this angle is 90 degrees. And then from point C, we drew perpendicular to BC, so this angle is a right angle. And we define the intersection point between the perpendicular from point A and the perpendicular from point C is point E. Point E is the intersection point between the perpendicular from A and the perpendicular from C. And then here we have actually so as you can see here, quadrilateral EABC is 1, 2, 3 right angles. We define this angle as angle A, as angle Y or X, whatever, and we know that the sum of the angles in any quadrilateral is equal to 360 degrees according to rule number 1. That is to say, 270 degrees plus the size of the fourth angle, that is X, must be equal to 360 degrees according to rule number 1. We subtract the 270 degrees from this equation and we know that the value of angle X is equal to 90 degrees. Okay? So here, this angle is a right angle, so quadrilateral ABCE is 4 right angles. According to rule number 2, any quadrilateral that has 4 right angles must be at least a rectangle, so we will relate to quadrilateral ABCE as a rectangle. Quadrilateral ABCE is a rectangle according to rule number 2, and according to rule number 3, the opposite sides of a rectangle are equal to each other. That is to say, AB equals to EC. AB equals to EC, but we know that AB equals to 4 units. So from this equation we will derive that CE also equals to 4 units. Here CE equals to 4 units. Likewise, AE equals to CB according to rule number 3. AE equals to CB. And if we define CB as X, then AE will be also equal to X. So AE also equals to X and CB equals to X. Okay, then we have actually the next construction that we did from point E, we do a straight line to point D, and from point D we do a straight line to point B, and we know that AE equals to X. And according to what is given us in the question, ABE equals to BC. Here you can see that AD equals to BC, as you can see here. But CB equals to X, so AD also must be equal to X. So AE equals to X, AD also equals to X, and CB also equals to X. So here, we know that this angle is a right angle, and this angle equals to 30 degrees, so 90 degrees minus 30 degrees is the value of this angle, that is actually angle EAD is equal to 60 degrees. And here we know that AE equals to X and AD also equals to X. So in triangle AED, that this angle equals to 60 degrees, we have two sides that are equal to each other. So I draw triangle AED in a new page, in this page. We know that this angle equals to 60 degrees, and we also know that AE equals to DAD. They are both equal to X. And we have the rule that in front of equal sides in the triangle there are equal angles. That is to say, those two angles must be equal to each other because they are located in front of equal sides. Those two sides that are equal to each other. So if this angle is Y, then this angle must be also equal to Y. And the sum of those two angles is Y plus Y, and Y plus Y plus 60 degrees must be equal to 180 degrees because of the fact that the sum of the angles in any triangle is equal to 180 degrees. Therefore, 60 degrees plus angle y in triangle AED must be equal to 180 degrees because of the fact that the sum of the angles in any triangle is equal to 180 degrees. Here we subtracted 60 degrees from this equation and we got that 2y equals to 180 degrees minus 60 degrees is 120 degrees. We divided this equation by 2 and we got that angle y equals to 180 degrees minus 2, that is to say angle y equals to 60 degrees. So those two angles that are angle y, and that's why they are both equal to 60 degrees because y equals to 60 degrees. So I found out that triangle ADE is an equilateral triangle because it has all angles that are equal to 60 degrees, therefore all of its sides will be equal to x because all of its sides are equal to each other. So triangle AED is an equilateral triangle. So I can write here also that ED equals to x. This angle is 60 degrees, this angle is 60 degrees, and this angle also equals to 60 degrees. Then we proved the triangle AOB is congruent to triangle EDC. Triangle AOB, triangle A, it is actually triangle ADB, congruent to triangle EDC. Those two triangles can go into each other. We proved that those two triangles can go into each other. Why those two triangles can go into each other? First of all, we know that AB equals to CE equals to 4 units. AB equals to 4 units and CE also equals to 4 units, therefore they are equal to each other. We also know that those two angles, they are both equal to 40 degrees, therefore they are equal to each other. That is to say that angle BAD equals to angle EDC equals to 30 degrees, and we also know that AD equals to ED equals to X. AD equals to ED, and they are both equal to X. So we actually proved that triangle ADB can go into triangle EDC according to angle side angle rule. Therefore, DC equals to BD. Here, BD equals to DC, according to the rule that corresponding sides of congruent triangles are equal to each other, but it is given as the equation that DC equals to 2 units. From this equation we will get that, we will derive that DB also equals to 2 units, BD also equals to 2 units. Then we focused on triangle ADB and we implemented the law of cosines on triangle ADB. I copied triangle ADB in a new page and we implemented the law of cosines on triangle ADB. So here, so in triangle ADB, actually didn't draw it a new page, but we implemented the law of cosines on triangle ADB. I mentioned the law of cosines on the first method. According to the law of cosines, here cosine 30 degrees equals to x squared plus 4 squared minus 2 squared over 2 times x times 4. This is according to the law of cosines. Cosine 30 degrees equals to square root of 3 over 2 x squared plus 4 squared is 16 minus 2 squared is minus 4. 16 minus 4 is 12, so in the numerator we have x squared plus 12. In the denominator we have 2x times 4 is 8x. We multiplied this equation by 8x and we got that square root of 3 over 2 times 8x equals to x squared plus 12. 8 over 2 is 4. So we got that 4 times square root of 3x equals to x squared plus 12. So we subtracted 4 times square root of 3x from this equation, and we got that x squared plus 12 minus 4 times square root of 3x equals to 0. And here we have x squared plus 12. We can substitute 12 by 2 times square root of 3 square, because 2 times square root of 3 square equals to 12. You can see it's very simple. It's very simple. Minus 4 times square root of 3 square. Here we substituted 4 times square root of 3 square by 2 times x times 2. So we actually substituted 4 by 2 times 2. And this equation, x squared plus 2 times square root of 3 square minus 2 times x times 2 times square root of 3, is very similar to the equation that a squared plus b squared minus 2 times ab equals to a minus b squared, when a is equal to x and b equals to 2 times square root of 3. So we can substitute this expression by a minus b squared. That will be also equal to 0, exactly like this expression, that equals to 0. What is a minus b squared? A is x and b is 2 times square root of 3. So a minus b is x minus 2 times square root of 3, and we square it together, and it must be equal to 0. We took a root out of this equation, and we got that x minus 2 times square root of 3 equals to 0. We added 2 times square root of 3 to this equation, and we got that the value of x is 2 times square root of 3 units. X equals to 2 times square root of 3 units, and also here we wrote that x equals to 2 times square root of 2 units. And now we can find out the value of quadrilateral ABCD, that it will be equal to the area of triangle ADB plus the area of triangle CDB. The area of quadrilateral ABCD equals to the area of triangle ADB plus the area of triangle BDC. What is so here we do perpendicular from point D to AB. So DS is the height to the base AB, and the area of triangle ADB will be equal to the base of the triangle that is AB times the height to the base that is H over 2. The area of triangle ADB equals to, okay, but first of all, what is the value of H? In triangle ADS, we know that sinus 30 degrees equals to AD over 2 times square root of 3. In triangle ADS, sinus 30 degrees equals to H over 2 times square root of 3. We multiplied, first of all, sinus 30 degrees is 1 over 2. We multiplied this equation by 2 times square root of 3. And we got that H equals to 2 times square root of 3 over 2. 2 over 2 is 1, so we found out that the value of H is square root of 3 units. H equals to square root of 2 units, and AB, that is the base of triangle ADB, equals to 4 units. Okay, so the area of triangle ADB equals to the base that is AB times the height to the base that is H over 2. AB equals to 4 units. H, we found out that H equals to the square root of 2 units over 2. And 4 over 2 is 2. In conclusion, we found out that the area of triangle ADB equals to 2 times square root of 3 units. The area of triangle ADB equals to 2 times square root of 2 units. And the only thing that is left to do is to find out the area of triangle BDC. We will find out the area of triangle BDC according to a special formula. First of all, we will find out the semi-perimeter of triangle BDC. the semi-perimeter of any triangle is equal to the perimeter over 2. So the perimeter of triangle triangle BDC is A plus B plus C. This is the sum of its sides over, and the semi-perimeter is the division of the perimeter by 2. So A plus B plus C over 2 is the semi-perimeter. A is 2, B is 2, and C is 2 times square root of 3. So 2 plus 2 is 4, plus 2 times square root of 3 over 2. 4 over 2 is 2, and 2 times square root of 3 over 2 is square root of 3 units. So in conclusion, we found out that the semi-perimeter of triangle BDC is 2 plus square root of 3 units, and the area of triangle DBC, it equals to, we use this formula in order to calculate the area of triangle BDC, that is the square root of S times S minus A times S minus B times S minus C, when S equals to the semi-perimeter of triangle BDC, that is, we already found out that it equals to 2 plus square root of 2 units. So S equals to 2 plus square root of 2 units, and so this is S. S minus A is 2 plus square root of 3 units minus 2 is square root of 3 units. S minus B is the same because A equals to B. It is also square root of 3 units times S minus C. S is 2 plus square root of 2, and C is 2 times square root of 3. So S minus C is 2 minus square root of 2 units. So here square root of 3 times square root of 3 is 3, and 2 plus square root of 3 times 2 minus square root of 3, we will calculate the value of this expression according to the algebraic identity that A plus B times A minus B equals to A squared minus B squared. A is 2 and B is square root of 3. A squared is 2 squared, 2 squared is 4, and square root of 3 squared is square root of 3 squared is 3. 4 minus 3 is 1. So the area of triangle BDC equals to the square root of 3 units, and the area of quadrilateral ABCD equals to the area of triangle ABC, and the area of triangle ADB, the area of quadrilateral ABCD equals to the area of triangle ADB, that is 2 times square root of 3 units, plus the area of triangle BDC, that is equals to square root of 3 square units. 2 times square root of 3 plus 1 times square root of 3 is 3 times square root of 3 square units. So we found out that the area of quadrilateral ABCD equals to either 3 times square root of 3 square units, or in terms of numbers, it equals to 5.196 square units. Okay? So we found out in both methods that the area of triangle of quadrilateral ABCD equals to either 3 times square root of 3 square units, or in terms of numbers, it equals to 5.196 square units. Okay? Thank you very much.